Welcome to another one of our Siemens Solid Edge portfolio webinars. This one is titled Reverse Engineering Made Easy with Convergent Modeling, and it's part of a series of digital transformation webinars focused on speeding your product development and manufacturing process and helping you deliver world-class products to your customers. My name is Ilya Nezarenko, and I'm your host and presenter for this webinar. In the interest of time, we will not have a separate Q&A session at the end of this webinar, but you can key in your questions to the Solid Edge Community Forum, shown at the end of this webinar, and we will get back to you to answer your specific questions. The Solid Edge portfolio is focused on driving a digital transformation for small and medium-sized companies. We see that these companies want complete, fully featured, and professional engineering tools. But they also need tools that are easy to access and easy to learn. As you will see in this webinar, the Solid Edge portfolio is more than just Solid Edge CAD. It's a complete portfolio of solutions for design, simulation, manufacturing, and technical publications. Also, we have tools for collaboration and data management. Combined, these solutions speed the complete product development process. With the Solid Edge portfolio, you can create detailed 3D digital models, also known as digital twin, of your proposed products, and use these as basis for all areas of product development, including concept and detailed design, prototyping, simulation, manufacturing, installation, and service. This digital twin also helps SMB manufacturers address major challenges like increased complexity and increasing regulations. I'm sure you have heard about reverse engineering and using the scanners to bring a physical part to 3D model. Nowadays, as the scanners are becoming more affordable, reverse engineering is becoming an essential workflow in CAD. The reverse engineering process involves measuring an object and then reconstructing it as a 3D model. The measured data alone, usually represented as a point cloud, which is lacking topological information and is therefore often processed and modeled into more usable format, such as triangular face mesh, set of NURB surfaces, or CAD model. Reverse engineering is often used by businesses to bring existing physical geometry into digital product development environments, to make a digital 3D record of their own products, or to assess competitors' products, or for any other purposes. It's used to analyze, for instance, how a product works, what it does, what components it consists of, and estimate costs. Would it be nice if the scanned data could seamlessly merge with your design and then be used in additive manufacturing process? Here is the challenge though. While the scanned data is a mesh body and lends itself well to additive manufacturing or 3D printing, the other data created using traditional 3D CAD is a BREP model. In most systems, mesh data and BREP or traditional solid model are not interconnected at all. So, we ask ourselves, how do we take these beautiful optimized mesh models and incorporate them into our existing design? Reverse engineering functionality in Solid Edge allows you to do just that. You can seamlessly bring in mesh data and work with it, extracting surfaces and converting the scanned data into 3D CAD models. It's especially important to extract the precise definition of critical for operation areas of the mesh model. This is an image of an early model sewing machine, never modeled in CAD before. If one of its components breaks, you could use a 3D scanner to reverse engineer the component. So that's what we have done. In this example, the main arm was scanned and saved as an STL file. Now with reverse engineering, we can continue working on this data in Solid Edge. Now let's open this STL file in Solid Edge. And let's explore the powerful reverse engineering tools that will allow us to work with it. You'll see that it's actually mesh body. In case we need to clean up the mesh, Solid Edge provides us with the ability to erase unwanted geometry using brush or box selection methods. With a simple fan select, we can identify the area that needs to be deleted. Notice that it deletes the mesh on both sides of the model. To fill and repair these areas, fill holes command works great as it identifies these open areas automatically. Using selected type of surface, it closes these areas. In no time, we're back to solid mesh body. Our goal here is to convert only some areas of this arm to regular CAD geometry, the ones that are interconnected with other components. This will guarantee the right fit and function of the arm. We'll start by using manual method of marking faces for extraction. It's easy and fun as working with coloring books. I first start with marking cylindrical face and then switch color and go after planar face. This method is very selective yet flexible. It allows users to focus only on the geometry that needed to be converted into CAD geometry. The next step is to fit a specific type of geometry based on previous selections. Different types of surfaces are available, which ensures precise fit with the original geometry. The new geometry can be further trimmed and stitched into a single body using solid edge surfacing tools. This is actually a great example of one continuous workflow within solid edge. But let's take a look at even more productive way of extracting geometry. I'm going to use an automatic tool for marking faces. Added flexibility here is that you are not forced to extract all color-coded faces, but only the preferred ones. However, when necessary, you can extract all faces at once. Let's focus on the mounting arrangement of the arm. I can easily identify all the faces that form the mounting clamp at the end. The process is very visual and user-friendly. It's very easy to understand and follow. Once we selected all desired faces, all we have to do is click Extract and system goes to work. You might notice that all the required faces are extracted in a single operation, saving time and effort. Users can easily combine both methods, manual and automatic methods, for even greater flexibility. Non-extractable markup is available as part of the reverse engineering functionality. It will make geometry invisible for the face fitting process. I might want to extract that planar face of that ear as well while I'm working on this. So now we're ready to add those couple extra faces into our selection of faces. So I'm going to extract first planar face, and then I'm going to go after that cylindrical face. And you'll notice that the process is very user-friendly and very efficient. Now we will rely on surfacing tools for extending faces to make sure we are ready to transition into a solid B-wrap body. This tool works great on cylindrical or planar surfaces, and in no time we'll extend surfaces to make sure that they all intersect properly for future trimming. Let's examine the extracted geometry. You can notice that the back face is angled. This is by design and I want to leave it that way. But all other vertical faces have to be perfectly straight. We can tap into modeling functionality here as we're working in Solid Edge. Synchronous technology will take care of this for us. In particular, face relate command works great for that purpose. Another inconsistency is that extracted cylindrical faces are not concentric. Again, synchronous technology comes to rescue. In no time, we'll align those cylinders and they are now perfectly axially aligned. Also, we might want to adjust the diameter of the external cylinder to match the original design. So let's take a look how it compares to our mesh body. Notice that we're adjusting the diameter parametrically, even though I've never created a single parametric feature here. This is another advantage of having synchronous technology in your corner, ability to work with geometry regardless of the source of the geometry. Another productivity boost comes from the usage of a single tool for trimming all the sheet bodies at once. You can see that it can be done very efficiently with the minimum involvement of trips to the toolbar. And finally, we can stitch together all the extracted surface, for now just cylindrical region. And finally, we have a solid B-wrap. Since the part is symmetrical, we can easily work on half of it and then mirror the design. Very powerful replace face command allows me to create a clamp opening in one single click. Let's continue working on the ear region. At this point, we can take advantage of solid edge sketching tools and quickly outline the shape of the ear. First including the outline of that cylinder and then adding couple lines. Since solid edge supports open profile, I need only the bare minimum of curves for outlining the shape and producing the solid. At the same time, we don't have to know the depth of that ear. We can reference the extracted earlier construction geometry and be done really quickly. We have another use for the extracted earlier geometry. We can create that hole by simply subtracting that sheet body cylinder from the solid body and be done in no time. Okay, before we start mirroring the body, let's get rid of that little undercut and then mirror the body to start finalizing our design. Solid Edge is a very powerful but easy to use tool. You can see how I'm able to use the same tool for manipulating geometry, whether it's closing the gap or replacing split faces with smooth surfaces. Rounding edges is a very simple process in Solid Edge. Users can select edges through the body without actually need to reorient their designs to get to a particular edge. Multiple edges can be handled in one single operation, and as you can see, I'm almost done, just a couple more edges. We're pretty much done here. Let's turn on the mesh body and examine the results. We have two bodies, the original mesh body and the newly created B-wrap CAD body. You saw the power of reverse engineering tools that come in Solid Edge. What is the underlying technology that allows us to seamlessly work with scanned data? This is a new technology we call convergent modeling. Convergent modeling allows us to combine and use mesh models and B-wrap models in one seamless environment. You can work on your mesh models with the very same commands you use on B-wraps, cut or add material, perform Boolean operations, etc. Let's see how we can complete the process of getting the sewing machine arm ready for manufacturing. Now that we have two bodies, mesh body and a solid body that were designed, we can easily substitute portion of mesh body with this new design. So how would we go about this? Because of multi-body support, we can easily add an additional set of faces extracted from the new design and convert them into a solid. So conveniently, I can select the whole body for this. We need to do this because of scan data imperfections. We have to remove the mesh in the clamp area for clean replacement. We will use this new solid as a tool to do that. But before we do this, we need to make some modifications. First of all, we have a lot of openings that we have to eliminate. Using Boolean operation, we can just easily subtract the plane and get rid of all extra faces that we don't need. The next step would be to lift the top face and convert this body into a suitable configuration. And finally, before we can use this body, we need to make some modifications in order to encompass all mesh geometry we want to get rid of. First, we'll match the angle of the original back face with the newly created one. Then we will change the angle of the outside faces. We need to extend it a little bit. As you can see, it's not completely covering the geometry. Now we just change a couple angles on outside faces, again with the purpose of encompassing all the geometry we need to get rid of. And Syncast technology performs flawlessly again here. We're not fishing for features to do that. We just pick the face and rotate. That's all that there is to it. Then we're going to change the angle on the back face to include all the geometry suitable for removal. And finally, we're going to extend the front face to make the whole body bigger. All of this is accomplished with Syncast technology again. Finally, we can perform Boolean operation, subtracting our tool geometry from the mesh. This is convergent modeling in action for you. We got beautiful cut, and once again we will use Boolean to connect the newly designed clamp with the mesh. Convergent modeling at our service, technologies that makes it possible. Here's the proof that we are actually back to a single mesh body. Now we can assign material to it. Solid Edge provides the full library of different materials available. Obviously, it's going to be aluminum for this arm. And finally, we can send this newly designed arm with a B-wrap representation of the clamp. Using Solid Edge interface, we can send it to 3D printer if we have one connected. So we complete the full circle of bringing the scan data into Solid Edge, cleaning it up, replacing the clamp mesh geometry with a B-wrap body, and preparing it for the manufacturing. The Solid Edge portfolio is focused on driving digital transformation for small and medium-sized companies. We see that these companies want complete, fully featured and professional engineering tools, but they also need tools that are easy to access and easy to learn. As you saw in this webinar series, the Solid Edge portfolio is more than just Solid Edge CAD. It's a complete portfolio of solutions for design, simulation, manufacturing, and technical publications. Also, we have tools for collaboration and data management. Combined, these solutions speed the complete product development process. You can download the trial version of Solid Edge at the link shown here, and this includes all Solid Edge reverse engineering functionality. Or you can contact a local channel partner to learn more. For existing customers, you will have access to reverse engineering functionality in Solid Edge Classic or Solid Edge Premium. If you would like to find out more about Solid Edge, you can call this number to speak to us directly, or you can go to this link to download a trial version of Solid Edge that you can use for free for 45 days. Thank you for joining this webinar. Enjoy the rest of your day.